We're going to finish section 5.4 now. So last lesson we talked about how do you derive E, and what we found is it was really one of the easiest derivatives we have. The derivative of E is E, and then you have to derive the exponent. You have the du piece. So integrating actually is pretty simple as well. If I want to integrate E, we get E. You will have to check for an adjustment. So again, because the derivative has that du piece in it, we have to make sure that the integral does as well. So we do want to look for an adjustment when I go through. Now, there are other types of forms from previous sections that could show up today as well. So I wanted to list those as well, just to kind of keep track of what we've done to this point with integration. The sections that we're working on in this first part of the chapter, 5.1, 5.2, 5.4, really go so well together that it's nice to kind of talk to them all at the same time. So the other forms that show up a lot, even with e's, are du over u. That is your natural log integral. That's what we did in section 5.2. And then your basic power rule. That's what this last one is just seeing that we have u to a power. So that comes actually from what we did in chapter 4. So this is from 5.2, and then this is from the end of chapter 4. Excuse me. So I'm going to take you through 8 examples, all kind of giving you a chance to see a little bit of everything here and talk about how we figure out what form it is, what adjustments need to be made, and how we get our integral. So if you want to pause as you're writing these down so you can kind of try them on your own, if you want to watch these and then maybe the later ones try on your own. So I'm starting off with some pretty basic ones. When you have just e to a power, that's the only thing in our integral, your u is going to have to be your power. So in this case, your u is 3x plus 1. It's your exponent. The derivative is 3, which we don't have in addition to the e. We don't have that 3, so we're going to divide both sides by it to get a 1/3 adjustment. And then as far as the form that it's in, this is an e to the u form. This is an e where the exponent is the piece that we called u, and the integral of e to the u is e to the u, so we get 1/3 e to the 3x plus 1. And we can use what we learned yesterday, which was derive the e, derive the exponent to make sure you get what you started with. Don't forget to plug the plus c at the end of your answer as well. Next one, your u, again, is your exponent, negative x squared. Derivative is negative 2x. You don't have a negative 2x, you actually have a 5. Couple things you could do here. You could pull the 5 out and then make your adjustment of dividing by negative 2. Or you could multiply both sides by negative 5 over 2. What that does is it gets rid of the negative 2 and it leaves you with the 5 that's there. So a couple ways you could do it. Either way, your coefficient should be negative 5 halves, whether you pull the 5 out first and then do the negative 1/2 adjustment or do it all at once. This is another e to the u because your u is just your exponent of your e. And so you get e to the u. So negative 5 halves e to the negative x squared plus c. So starting off with just that newest form, that newest model we're looking at, pretty straightforward. Showing you some that are a little different. Obviously, they have e's in it, which is why it's in today's lesson, but it's not an e to the u form. So this first one is an example of when you have a power rule here because your inner piece is actually a piece that's being taken to the third power. So your u is 1 plus e to the 2x. You're going to see these whenever you have something either in parentheses to a power or something under a radical or something in the bottom under to a power under a radical. The derivative of 1 plus e to the 2x is 2e to the 2x. That's why this is there. That's your du part. You don't have the 2 coefficient, so you're going to do a 1/2 adjustment. And then this is a form from end of chapter 4. This is a power rule. This is a u cubed du because that's what's being done to it. So power 1 greater divided by that power. We end up getting u, which was 1 plus e to the 2x to the 4th all over 8 plus c. So showing you a power rule 1. When you have an integral that's a fraction where the numerator and denominator are really, really similar, you'll notice there's really only one difference between the two. You want your u to be the bottom. The hope is that you can get this to be a du over u. You're never going to have your du in the bottom, so that's why you want u to be the denominator. The derivative of e to the x plus e to the 2x is e to the x plus 2e to the 2x, which is exactly what you have on top. So that's your du. That's your u. Remember, that is the only time we don't do a power rule is when it's on the bottom to the first power. Power rule won't work here. This is a natural log form, so we get the natural log of the u. You do want to put your natural log, whatever you're taking the natural log of, in absolute values. What that does is it guarantees that you'd only take the natural log of something positive. And I tried on Delta Math to make sure that if you do have to enter a natural log, the absolute value bars is a button that you can access. I didn't mention this in the beginning, but you can actually have an e and trig combined. We did a little bit of this with derivatives yesterday as well. So with this one, your u is your exponent. So this is kind of e to the u like what we started with, but it has trig in it. The derivative of cosine is negative sine, which is exactly what you have. You don't even have to adjust with the negative. It already had the negative there. So this is just a perfect e to the u. It looks awful to start because of the trig. You have a sine, you have a cosine exponent, but it truly is just e to the u, and the integral of e to the u is e to the u. So you get e to the cosine. And if you derive that using what we learned in the last lesson, you get what you started with. Next one is more similar to the one on the previous screen. Again, you have this denominator. You're going to try that to be your u. The derivative of it is 2e to the x. You've got the e to the x. There's your du part. You don't have the 2, so we're going to divide by it. This is a du over u form. Again, looking for that form to be our natural log form. So you get 1/2 the natural log of 1 plus 2e to the x. You could also write the 1/2 as the power. So you could say it's natural log of the square root. I usually don't do that. I think it's easier just to use this form, especially if you have an absolute value button close by. 2 more. So number 7 is also a basic e to the u. Your u is just your exponent. Now you are going to want to think of that exponent as x to the negative 1. The derivative of that is power out front, power 1 less. So you end up getting negative 1 over x squared, which is almost what you have. If you look at this, here's your x squared piece in the bottom, which is what you want. You don't want the negative, or you don't have a negative, so you're going to multiply both sides by a negative 1, or you can just put a negative in front of your integral sign. This again is just an e to the u, and the integral is itself, so negative e to the 1 over x plus c. And then finally, we're going to finish with a power rule one. So our whole thing, this whole piece is in under the square root, so that's going to be your u, so e to the 4x plus 5. Your du, you'll notice with these, you always have something extra there, and that's because when you derive, you're going to have an e again. Your du is going to be 4e to the 4x. You don't have a 4, you have a 2. So to adjust, you're going to divide both sides by 2. This is a power rule. Because u is being taken to a power, it's being taken to the 1/2 power since it's under a square root. So power 1 greater divided by that power would be 2/3 u to the 3/2. Cleaning it up a little bit, you can cancel the half and the 2. The 3 is still on the bottom, and put your u back in. So you get e to the 4x plus 5 to the 3/2 all over 3 plus c. They are going to ask that you put it in lowest terms, but you can write it in any notation with that exponent. I think leaving it with a 3/2 exponents is easier. So that's your basics of integrating with e. You'll notice some of them are brand new. Some of them kind of incorporate e with other forms that you've already learned.